All right. Hello, everyone. Welcome to the Gardener Community Review meeting. Today, we're focusing on the Gardener release 142. And on our agenda, we have a few topics. So I'm going to start presenting the new backup entry for the garden cluster. Then Oliver will continue with the removal of our control plane Helm chart in this release. Marcel will then follow with a configuration for the deletion propagation in managed resources or for managed resources. Then Tim will present us the Gardener in Docker setup. And Prashant will be the last one or presenting the last item on the list, and which is about another or a new configuration option called maxBinpackingTime for the cluster-autoscaler. All right, so I'm going to start with the first topic. Took this over from Raphael since he's out of office today. So it is about deploying a backup entry in the garden cluster use case. So you probably already know the backup entry and backup bucket concept from shoots. So if you enable backups and have shoot clusters, then you usually have a backup bucket per seed. And then per shoot cluster, you have backup entry. And the relation is that, just that the bucket is reused and every shoot gets an entry in this bucket where the backup is then placed. For the garden scenario, we haven't had this before. So we placed a more or less shortcut in that scenario because you only have one garden cluster, or it's only possible to have one garden cluster at the moment. And thus we only use the backup bucket and hard-coded the entry inside, if you will. But in order to make this consistent, we decided to also deploy a backup entry. So I deployed a local garden cluster. This one, it is deployed with the previous version. So what can we find here? So we have one, do it this way. We have one backup bucket. And if we check the backup entry, it even tells you that it doesn't know about this resource. So it's pretty simple, I guess. As I said, we just used the hard-coded entry in this bucket and didn't need the entry. And I deployed, after this setup, I deployed a new version with the change. So let us reconcile the garden resource. And check if there's going to be an entry. So the bucket is still there, of course, and this will stay like this. And in a few seconds, we should see another backup entry. And the name of the entry follows the same name that was used before, as I said, with this hard-coded entry in the bucket that happened behind the scenes. So this is the bucket name. It's the namespace of the garden, which is garden, and then the UID of the garden resource. And by sticking to the same name scheme, we allowing for backwards compatibility, of course. So we just introduced the entry, but the location is still the very same that was used before. So we don't lose any backups or need to do any migration path here as well. Okay, and now this is, as I said, consistent to what is happening already on the seed. And if we check, for instance, for the secrets, we see there's a new secret called etcd backup. This one was created by the by the generic controller, by the generic actor, by the extension, and is then considered when configuring the entity. So no more hacks behind the scenes or no more shortcuts behind the scenes, just consistency. Okay, I think that's it about this topic. Do you have any questions? Okay, then thank you very much, and I'll hand over to Oliver.
Yeah, good morning, everyone. I'd like to present this nice PR. Raphael and me did together, and yeah, Raphael is out of office, so I have the honor to present it. Yeah, this PR is the end of a long journey. We announced it last year, I don't know, beginning of last year, that we tried to get rid of the garden control plane Helm chart. And now we finally did it. I hope everyone migrated to the Gardener operator. Otherwise, it's a good opportunity to do so now. Yeah, I prepared a short demo for this. So here you see Gardener v1.142, and it templates a nice Helm chart. And in the new version, when I run the same command, it will not found. Okay, so that's it about the demo. Yeah, I could spend the rest of the time by walk you through the changes of the dev setup, because our dev setup was one of the last places where this control plane Helm chart wasn't used, and finally, we migrated it completely to the operator too, and we have a completely new structure. So I walk you through it a bit. Okay, when you have a look at the Gardener repository, you might notice there's a new folder. It's called Dev Setup. And this is the new place for for everything which is related to Dev Setup. When we move in here, we see we moved many things which were spread across the repository in this single folder, like the scaffold files, but also the scripts we use for the make targets, and of course the configs. And there's also a short README which describes how this setup works and how the structure looks like. I think that's also something new. We haven't had it before. In the end, when you just do things like make kind up, Gardener up, it will still work. So we changed things under the hood. This common start of the dev setup is still the same. However, it might make sense to see all the different make targets which are called by this, because those are aliases to the new world. And I prepared not a live demo, but a static demo, because it takes so long. I started a local setup, a new local setup on my machine. You start with make kind up, which is an alias for here, make kind single node up, which is starting as before the kind setup. What's important here, this call defines which scenario you are using. Before we could continue with scenarios like make gardener multi-zone up and whatever. That's gone now. So now you decide when you start your kind cluster which scenario you use. So here in this case I started the single node setup, and a bit later, next command, make operator up, and you see here it detected the scenario single node, and it's continuing the operator setup with this setting. And this works also for other setups like multi-node, multi-zone, then the according scenarios detected. And it also works for the remote setup I presented a while ago. Same happens for the subsequent commands, like here, make garden up, which creates the garden. Again, single node scenarios detected. And last but not least, the seed up. Oh, it should be at the bottom of my screen somewhere. Yeah, a bit hard to find. We have debug logs enabled. Here for the seed up. Yeah, it's the same thing. Okay, let's go back to the repository. Another important thing, once you started your setup, you might want to access it. And there's another new thing is we have now a common folder for all the kube configs. So here it's the dev setup kube configs folder. And within this folder, all the kube configs for these objects are copied to, of course, only if they are up and running. So like the runtime folder includes the kube config of your kind cluster. Most of the cases, the seed folder is doing the same. The seed2 would be like when you add a second seed. And important now, of course, is that there's also a virtual garden folder because we don't have this combined cluster virtual garden runtime cluster anymore. There's a separate kube config for the virtual garden as it is for the real landscapes. Okay, that's almost it. Maybe one more thing. Under the hood, we use Customize now. Before we had Helm charts and kubectl commands and so on. And now we are using primarily Customize. And when you look in a folder like here for the garden, it's always set up in a similar way. So we have a base folder, which includes the common configuration, like here for the garden. Then we have the components folder. And the components folder, components are a variant of customization. See it here. It does not include new resources, but it may include patches of existing resources. And with this components, we change the base object, like in this example, the garden, according to the scenario. And how this is tied up, I will show in the next step. So here, for example, it's adding the zone 0 to the garden. And the final result you see, you find in the overlay folder. And here I took a multi-node setup, and it's multi-node is not a nice example. Let's do a multi-zone thing. And you see here the multi-zone setup. It's the base garden, and it adds 2 components, like for the different for the second and the third zone. And that's how the entire dev setup folder is structured. It's like the same for a gardenlet and so on. You find it across the scenario. And in case you might wonder why this happens in your setup, it's a good idea to start here with an overlay folder. Check the overlay for the setup you are running, like multi-zone, and then see which components are included and to start changing, debugging them. Okay, I think that's basically it. I'm open for questions now. Please go ahead.
Is there a common way to apply this also to extensions? My question is because I've seen many extensions trying to adopt to this new architecture, and they all seem to have some different form of approach to doing this. Some use customization, some use here docs and shell scripts, and it feels a little bit unguided. Is there a common pattern to applying this new way also to extensions, or is it documented somewhere?
I'm not aware of it. Maybe we can work on it. It would make sense. I'm not too familiar with the extension setup or the dev setup in extensions. But it would make sense to have a common way.
Yeah, I think the problem is with the extension is bigger. In my opinion, we have the same setup, the same boilerplates, the controllers, the dev setup, and so on, duplicated across many repos, and everyone maintains them the way they want. And I agree that there is no unified way. This is what I wanted to say. So it's not tightly related to a dev setup, but more or less to everything.
Okay. Anything else?
Then maybe we can clarify that in form of an issue or a Slack discussion after the meeting, which totally makes sense. Thanks for bringing it up. And just one comment. I really appreciate and like the new structure. It's very consistent and clear. A very big improvement in this area. So thank you for taking care. Especially I like that you're now really easily find the cube configs that you're searching for. That's awesome. Okay, good. So thank you very much, Oliver. Next up is Marcel.
Yep. I will be sharing a short new feature that I added to the managed resource or the resource manager. So in this small demo, do you see my screen? Just a quick confirmation. I have a managed resource that deploys that contains a deployment. And so deployments have immutable fields. So if I want to change the label selectors, I get an error in the resource manager that I'm doing an invalid update. There already has been this feature in the resource manager where I can add an annotation here to say, please delete this resource if you detect an invalid update. But that is usually not what I want for deployment, because that also causes all the pods to be deleted. And now I should get it recreated. Maybe I had a different error. Annotations. No. Okay, maybe I had a small white space error in my YAML. But the resource manager deletes the deployment that cascades to the pods. So now I added a new annotation that you can set here as well. Cascade. Where is it? This one. So it's a long annotation. So deletion, propagation on invalid update. You can set it to orphan, foreground, or background. But I mean, background is the default, and orphan is usually what you want if you want to change this behavior. So now if I set a different label again, name nginx, this is also an immutable update or an invalid update. But now this time we see the deployment was recreated, but the pod stayed. So this applies to all kinds of resources where you would find this. I needed this because I wanted to update some deployments and avoid restarting the pods unnecessarily. So yeah, that's it. Small feature, but if you need it, you're happy that it's there.
Thank you very much, Marcel. One question, do we still need then both annotations as you showed?
Yes, you do need both.
Okay, thank you. Okay, then no more questions. Tim can go ahead with the new Gardener and Docker setup.
All right. I'm presenting yet another PR that Raphael opened, but actually we started working on this at the hackathon in December. And now also this larger chain of PRs is coming to a close, and hence I'm presenting what we have today with the latest release. It's called the Gint setup, meaning Gardener in Docker, which is very similar to Kind, which is Kubernetes in Docker. But instead of creating a cluster using kubeadm like Kind does, we use Garden ADM now that we have it. So all of this is part of the larger self-hosted shoot story, so get 28. And with this setup, we basically replace the previous development setup where we started machines on a Kind cluster locally. Now we use Docker containers directly. So if you develop the unmanaged infra scenario, you don't need a Kind cluster anymore. We just use what we already have with Garden ADM. This document outlines how you can get started on this. So still a word of caution, Garden ADM is still under development. It's not ready for production environments yet, but you can very much use it in the local development setup. And as you will find here, there's a new command, make gint up, which deploys some machines and so on and so forth. You will see it in real life in a second. But there are also different scenarios, meaning the level of provisioning you would like to accomplish. The first scenario is just starting the machines via Docker Compose, and then you can run Garden ADM on it manually. This is probably useful for developing changes in Garden ADM in it or something like that. The default scenario, which you don't need to select, it basically starts the machines and initializes the control plane on the first machine. Join does the same, but also joins the second machine as a worker node. And connect is basically the highest level for now included in this release, where you also deploy the Gardener operator, create a garden cluster with it, and then run garden ADM connect so that the shoot gardenlet is deployed. And this is what I have already prepared because it takes a bit of time. I executed this particular command. If you don't have so much time, you can also use the fast equals true environment variable, which will skip a few steps like transitioning to the etcd druid and redeploying extensions and resource manager in the pod network. This will be much faster. If you just need a quick cluster, you can use that one. Okay, so in my local setup, there are many Docker containers now. You will recognize some of them, like the registry containers, the registry itself, and the caches that we already had before. There's also the bind9 for the local DNS. And now there are 4 machine containers. These are managed by Docker Compose, along with a container for running a load balancer in front of the API server. This is also similar to what kind does when you create a kind cluster with multiple control plane nodes. This one is a load balancer that the local cloud controller manager created for exposing the virtual garden. So I'm using the kubeconfig in this nice new kubeconfigs directory that we have seen before. And there is the self-hosted shoot directory, and here we should see that 2 nodes join the cluster. One is the control plane node and the other one is the worker nodes. The other 2 containers are not used yet, but we will be able to join them as additional HA control plane nodes later on once Garden ADM supports that. Okay, apart from that, the Gardener operator is running on this cluster. And we successfully created a garden. So there's the virtual garden as we've seen, and we also connected this self-hosted shoot to the garden by running the garden ADM connect command, which basically deploys the gardenlet inside the kube system namespace. So with this, we can also access the virtual garden using the corresponding kubeconfig. Similar path, different directory. And here we should see in the garden namespace that gardenlet registered the shoot for the self-hosted shoot. You can also take a look at it. So this one should have the control plane section in one of the worker pools, which marks the shoot as a self-hosted shoot. That's all I wanted to show for today, but the next enhancement to this setup will be to also promote this self-hosted shoot cluster to a seed. This landed in the upcoming release, so I'm pretty sure we will see a demo for it soon. But this is basically the completion of this larger story with the GIN setup, where we use what we have with Garden ADM and self-hosted shoots instead of using kind with Cube ADM. Any questions?
Thanks, Tim. That's really nice to see. Do you have a rough gut feeling of how much more work it takes to be actually able to convert one of the end-to-end tests onto the GINT-based setup?
I think we should be able to do so now that this upcoming PR here is completed with the managed seed. We might try it out, but I feel like there was some there wasn't so high confidence to switch all of the end-to-end tests at once. So maybe we want to try it out in one job first and see how our experiences with that are. It definitely means waiting on end-to-end test results a bit longer because bootstrapping a Gint cluster takes more time because our self-hosted root clusters also target a higher production grade than kind. That's why it takes a lot longer and might therefore also be a little bit more unstable, at least in the current state where we haven't made Garden ADM production ready just yet. So yeah, I guess we will have to try it out and see how it goes.
Makes sense. And I agree, probably makes sense to start with one test suite first before doing a big bang change. Final question, so is Gint now the canonical pronunciation for the tool?
If you agree.
I agree, that's it.
Perfect. Okay, then it's set in stone.
Nice that we also talked about this in that meeting. Another question from my side, is it already decided that Gint will replace the kind-based setup, or will we support that side by side?
I don't think that's decided just yet, as we need to gain more experience with the setup. As I said, it still makes sense to have the kind setup because it's faster. But let's see, maybe we can tweak it some more to make it similarly fast for some scenarios. Yeah, still open for discussion.
Sounds good. Thank you. Okay. More questions regarding this topic? If not, we will continue with the last topic. Prashant.
Is my screen visible?
It's visible, yes.
This one's a fairly simple change. It's just exposing one additional cluster-autoscaler flag in the chute, which is maxBinpackingTime. By default, the value for this field is 5 minutes, and this in this demo I'll just show you why this might be useful. In what cases you might want to tweak the default value. So yeah, this time basically specifies to the autoscaler how much time it should spend on bin packing for a single scaler. And if this timeout is breached, autoscaler just scales up whichever is the most optimal node group evaluated at that point. So where this particular bin packing time is checked for is in the scale up method for autoscaler, where it would filter out all the valid node groups for your unscheduled pods, and then it would iterate over all the valid node groups, check the expansion option, and if the bin packing time is reached, then it stops evaluating all the node groups and picks the best option from whichever ones it has evaluated so far. So for this demo, I'll be working with a bunch of node groups and demo pod, which would be unscheduled pods, which would be passed to autoscaler for scale-up simulations. So the node groups that I've defined are NG-A0, which uses 8 CPUs, 16 gigs memory. Then another one which uses 16 CPU, 32 gigs, and NG-A1, which is similar to NG-A0, it's just a difference in name. And the best option for these particular pods, which is NG-BEST64G. Those are the node groups, and this is the pod which will be trying to scale up scale up nodes for. So the pod requires 6 CPUs and 12 gigs of memory, and we'd be deploying 10 such pods. In the demo scenario, we will be running autoscaler with the bin packing time set to 1 milliseconds. This is an atrocious value, but this is just for showing the difference between how autoscaler evaluating all node groups versus it only evaluating some of the node groups. So we will be running autoscaler twice, once with one millisecond bin packing time and the second time with 1 second, and see the differences in result. So here I've created a bunch of node groups for the autoscaler, where the autoscaler would be running the Quark cloud provider, and it will use these node groups as input for scale up computation. And the pods that I have deployed use the 6 CPU and 12 gigs memory, and I'll be deploying 10 such pods. I'll be running CA with 1 milliseconds bin packing time and 1 second's bin packing time, and we'll check the results. So this is just a tool that I have that I'm developing right now, where you can run cluster autoscaler or carpenter, and you can specify some inputs and workloads, and you can observe how the scaling happens for the particular scenario. So this time I'm running it with the bin packing time set to 1 milliseconds. Let's see the results. So this essentially runs all the control plane components as Docker containers, and then you deploy the dummy pods, and then autoscaler Quark cloud provider creates fake nodes for these for this dummy workload to be scheduled on. So we can see that we deployed 10 such unscheduled pods, and the autoscaler scaled up group A016, which has 16 gigs allocatable memory. Yeah, so it scaled up. In total, we can see that it scaled up 10 such nodes. So that was the first result. We can check the autoscaler logs as well to see what was the expansion computations. Yeah, so here we can see that autoscaler prints out that the bin packing was cut short due to it exceeding max bin packing duration. And then it only evaluated one node group, which was A016G, saying that it would waste 25% CPU, 25% memory, and it resizes this particular node group. So that is with bin packing time set to 1 milliseconds. Let's try it with 1 seconds now. As you can see, the node group that was scaled up was node group best 6, which has 64 gigs memory, and it needed to scale up 2 such nodes to satisfy the scheduling requirements for all 10 such pods. So let's check the CA logs for this. As you can see, because CA had ample time to evaluate all the candidate node groups, it evaluates all of them and finds that for expanding this group best64G, it leads to lesser wastage. So it picks that as the best option to resize. So that was basically it for the demo. The default, just a disclaimer that the default value of 5 minutes is ample time for CA to do its computation. The only cases where you might require increasing that value is if you have a lot of node groups defined, couple hundreds of node groups, and you have the amount of unscheduled pods is also a huge amount, so hundreds of thousands of pods. That is the case where in reality, CA might hit this 5-minute bin packing limit, and you might see scale ups which might not be the best candidates for scaling up. So yeah, that was basically it for the demo. Thank you for watching.
Thank you very much, Prashant. Maybe a question from my side. I don't know if I understood correctly, but 5 minutes seems like a very high value, and I'm wondering, when does this 5 minutes time window starts? So does it start when the first pending pod is recognized in the cluster, or how does it work? Do you know that?
So this limit is for the actual scale-up method that CA is running when it's doing the scale-up simulations. So when it gets a bunch of unscheduled pods, and then it starts simulating and evaluating the node groups for them, that is when the bin packing timer actually starts. And during when it has found out a set of candidate node groups, when it is evaluating them, that is the point at which it might stop bin packing if the bin packing time is breached.
Okay, but this also means if I have a cluster which is more or less full, and I schedule or create some 10 more pods as you did in the demo, then it might take 5 minutes until the new node will join.
No.
Or will scale up, or?
So once CA has evaluated all the candidate node groups, then it can pick the best expansion option out of those. It doesn't wait the entire bin packing time. This is just a limit.
Okay, got it. Yeah, thank you very much. Now I got it. Okay, are there any questions regarding this topic? Now you have the chance to raise it. Okay, I assume everything is clear. This was the last topic for this meeting. Thanks to all the presenters and all the contributions in this release. Just a short reminder, so we will meet again next week already for the next review meeting. It's May 27th. Yeah, I wish you a good time until then. Happy to see you next week, and thank you.
Thank you.
Thank you very much, everyone.
Bye-bye.
Bye-bye.
See you next week. Bye-bye.